Hello class, good afternoon. So our topic for today is prime factorization. When a number is written as a product of factors that are all prime, the string of factors is called the prime factorization of the number. So there are two ways in getting the prime factorization of the number. It can be using factor trees or continuous division. To get the prime factorization of a given number, we can use the factor trees or the continuous division. So here is the example of factor trees. So first is, think of a two number or think of two numbers that when you multiply, the answer is 18. So 2 and 9. Remember that our goal is all the string factors must be prime number. I will repeat, all the factors that will come out must be prime number. So since 2 is a prime number, so we'll end with that one. Then we'll proceed here in 9. So 9 is not a prime number. So we need to think again of two numbers that when you multiply, the answer is 9. So 3 times 3, the answer is 9. As you can see, 3 is a prime number. So all the factors now are prime number. So this is what we call the prime factorization of 18, and we can write it as 2 times 3 times 3. So the prime factorization of 18 is 2 times 3 times 3. Another example using factor trees is 30. So think of a number that when you multiply, the answer is 30 or the product is 30. 2 and 15. So 2 is a prime number, so we'll just proceed with 15. Think of two numbers that when you multiply, the product is 15. So 3 times 5. So this one is what we call the prime factorization of 30. So when you multiply these three digits, the answer must be 30. So 2 times 3 is 6 times 5 equals 30. So the prime factorization of 30 is 2 times 3 times 5. Mind you that the prime factorization must be prime numbers. All are prime numbers. If they will ask you, is 6 times 5 prime factors or prime factorization of 30? Not a prime factorization. Not a prime factorization. Why? Because 6 is not a prime number. I will repeat, 6 times 5 is equal to 30. This is factor of 30, but this is not prime factorization of 30 because 6 is not a prime number. All must be prime number in prime factorization. Another way of getting the prime factorization of a number is using continuous division. So our fair example is 18. So think of a prime divisor of 18 or think of a number that you can use in dividing 18. It must be a prime number. So since it ends with 8, so we can say that this is divisible by 2 and 2 is a prime number. So we can start to divide by 2. 18 divided by 2 is 9. Next, use the quotient as the dividend. Then think of a divisor of 9. Prime divisor of 9. So 3. 9 divided by 3 is 3. So 3 divided by, since 3 is a prime number, we can divide it by itself to get 1. We should end by 1. In using continuous division, your last quotient must be 1. So this is our prime factorization for 18. So the prime factorization of 18 is 2 times 3 times 3. Your prime factorization must be equal to the number. So 2 times 3 is 6 times 3 is 18, and that is continuous division. Another example for continuous division, so we'll find the prime factorization of 70. So you can see that 70 ends with 0, so this is a multiple of, or this is divisible by 2, which is a prime number, and by 5, which is also a prime number. So let's start it by 2. So 70 divided by 2, the answer is 35. Next, use the quotient as the dividend. Then think of another prime divisor of 35. So since it ends with 5 and 5 is, so it is divisible by 5 and 5 is a prime number, so we can divide it by 5. So 35 divided by 5, the answer is 7. The next 7. Since 7 is a prime number, so we can divide it by itself. 7 divided by 7, the answer is 1. So we end with 1, meaning it is the last step. So this one is the prime factorization of 70. The prime factorization of 70 is 2 times 5 times 7. All the string factors are prime number. For your activity, answer practice A and B on page 167. Write your answer on a sheet of paper. Take a clear photo of your answer. Send it via private message. Deadline October 27.